Hello, so now I'll be doing set D differentiation question 2. I don't know if I do have much time to do the rest, but I'll just do what I can. Okay, so let's go into the first question, which is given fx equals to x, 4x squared plus 2x minus x squared plus 5x, find f prime x. Okay, so since they didn't say to use whatever rule, I'm just assuming I can expand it, which is gonna be 4x cubed plus 2x squared. Okay, and then let's just minus that, and then since we have a negative sign here and it's positive, so it's going to be minus 5x. Okay, so now we can simplify the equation. 4x squared plus 4x cubed plus x squared minus 5x. So that would be fx. Now let's find f prime x. Okay, let's see, f prime x is gonna be 12x squared plus 2x minus 5. So that is the answer for A. Okay, next, okay, given y equals to 3x to the power of 4, right, okay, plus 2 over 2x, find dy dx using the quotient rule. Okay, so what is the quotient rule? Quotient rule is used when you have a fraction. So basically we're gonna let u equals to whatever and then let v equals to whatever. So we have the equation y equals to 3x to the power of 4 plus 2 over 2x. So first what I'm going to do is I'm going to let u equals to normally people will write it like this, but I'm too lazy to write that, so I'm just going to write let u equals to 3x 4 plus 2 and then I will immediately differentiate that. So it's going to be u prime equals to 12x cubed. Okay, then I will let v equals to the denominator, which is 2x, and then v prime is just going to be 2. Okay, so now we can actually use the quotient rule by doing this. Dy dx equals to, the formula is vu prime minus u v prime over v squared. Right. Yeah, I think so. Okay. So let's just multiply all of that. V is 2x. 2x and then u prime is 12x cubed. Minus, okay, 3x 4 plus 2, and then we have 2, and then we need v squared. V squared would be 2x squared. So I'll just continue here. Okay, so that is gonna be 24x to the power of 4 minus okay, 6x 4 plus 4 over 4x squared. Okay, so I can, hold on, oh wait, no, I can't do that yet. Okay, so I have to take it out of the bracket first. 24x to the power of 4 minus 6x to the power of 4 minus 4 over 4x squared. You see, this is where most of us get it wrong, because sometimes we just throw away the bracket and then we didn't take into account for the plus sign over here. So my advice is we just leave the bracket on and then we do this step. Yes, I know it seems to be like an extra step, but it's better to be safe than sorry. So yeah, unless you're able to like chonga it, then go ahead. But if you're clumsy and you do careless mistakes like me, then better you do the bracket first and then you take it out of the bracket, considering the sign in front there. Okay, so let's simplify that. 18 to the power of 4 minus 4 over 4 squared. Okay, yeah, I think we can simplify it further. Okay, let me just move this up here. Okay, so let me I'll break it first to make it easier to look at. Minus 4 over 4x squared. Okay, so let's divide it by 2. 9x to the power of 4, and then 2x to the power of 2. Okay, wait, you know what? I'll do this first so it's easier for all of you to see. 1 over 4 over 4 is 1, so 1 over x squared. So over here, I can just, when the denominator, you're bringing the power to the top, it's going to be minus. So it's going to be something like 9 over 2 x to the power of 4 minus 2. So I'm just going to immediately write the answer, which is going to be squared minus 1 over x squared. So that is the answer for B. Let me bring this up here. Okay. Given the function fx equals to 5x to the power of 4 minus 4x to the power of 3 plus 12x to the power of negative 1 plus 24, find the first, second, and third derivative. Okay, so first, they already did us a favor by doing negative 1. Thank you so much for that. So let's first find the first derivative. Oh, they want first, second, and third. Wow. Fx. So if it's fx, then we have to do f prime. When they give you fx, don't do dy dx. You should follow what the variable is given. But if you are given y, or I don't know, z or t or whatever, then you can do dy dx, dz dx, dt dx. Depends on like what the variable given is. Okay, so let's differentiate. Okay, we have 4 times 520x cubed minus 12x squared. Okay, it's gonna be minus 12x negative 2. Okay, that's not 24 because, yeah. Okay, now for the second derivative, it's gonna be f prime prime x 60x squared minus 24x plus 24x negative 3. Okay, f prime 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 x is gonna be 120x minus 24. Wait, hold on. 24 times negative 3, that's gonna be negative 72x negative 4. So we've already found all three derivatives. Okay, so the second question, given f x to the power of 4 over 2 minus 2x to the power of 3 plus 3x, show that f prime prime x equals to 18 when x equals to 3. So basically, we still have to do second revision. So let's do the first one. What I like to do first is I like to convert it into I like to bring the x upwards normally. But in this case, it's just the normal x to the power of 4 over 2. So I won't do that. So I'll just 4. Yeah, so it's going to be 4x cubed over 2. Later I will simplify it. 6x squared. And then plus 3. So it's basically 2x cubed minus 6x squared plus 3. Okay, so now f prime prime x is equals to 6x squared minus 12x. So that is f prime prime x. So now what the question wants is when x equals to 3, it is supposed to become 18. So let's substitute x equals to 3, f prime prime 3 equals to 6, 3 squared minus 12, 3. So 6 times 9, 54, and then 12 times 3 is 36. So 54 minus 36 is going to be 18. So yeah, it's proven. By the way, this means when you substitute whatever inside the equation, basically it means parameter. So in this case, our parameter would be 3. So you have to write that down to indicate that, oh, I'm substituting 3 into this equation. Okay, next would be a KY question. I noticed the format that is given would normally be, they will ask just normal differentiation, and then they will ask about quotient rule or product rule, and then higher derivatives, first, second, third, fourth, whatever. they could ask about the nature of the graph, but in this case they didn't ask it yet. I think down here maybe they're gonna ask about the nature of the graph, which is where you're gonna use the second derivative. And then there's going to be a K-bar question. So in the K-bar question, you're supposed to use all of the knowledge you've learned in this topic. Okay, so let's look at this. The cost of building a small pond in RM is modeled by Cx equals to x cubed minus 6x squared plus 9x plus 20, where x is the diameter of the pond in meters. So sometimes some students would misunderstood the question, where over here this just means the diameter. This whole equation doesn't mean the diameter itself, so don't get it wrong. Okay, so first find the first and second derivatives of Cx. So earlier, like I said, if they give you something like C, only C, then you are supposed to write dc dx. But if they give you like a function type Cx, then you need to write C prime x. That is how the writing the equation works like in differentiation. Okay, so first find the first and second derivatives. So let's do that. I'll do it here then. Okay, C prime x equals to 3x cubed 12x plus 9, and then we have C prime x for the second derivative. It's going to be 9x minus 12. Yeah. So those are the first and the second derivatives. I'll just put that here lah. Okay. Next, determine the coordinates of the turning points. So I do want to explain that what are the differences between first derivative and second derivative and the original equation. So most people, they don't really understand what is the function of derivating it first time, second time, and so on. But in this scenario, the original equation is the cos. So this is the cos. And then the first derivative means the rate at which the cos is changing. Basically maksud dia is rate tu berubah macam mana. Rate cos tu berubah macam mana. Okay, and then the second derivative is the nature of the graph. So I'm sure, I don't know how this graph will look like. Let's just say something like this, macam tu. Like a graph will look like this, right? So the second derivative here is meant to determine the nature of the graph. Maksudnya, graph tu ada maximum point ke, ada minimum point ke, macam mana? And you know, since this kind of question, they don't give you the graph itself, how are we supposed to determine the nature exactly? That is where the first derivative and second derivative comes in handy. So that is the explanation why we need to derive it for the first time and the second time. Okay, so in this case, determine the coordinates using determine the coordinates of the turning points. So when we want to find the turning points, what we're going to do first is we're going to set the first derivative as 0. Okay, basically we're going to do okay, wait, you see what I mean, because I don't know what the term for it is. So basically C prime x equals to 0, which is 3x squared minus 12x plus 9 equals to 0. We're going to do factorization. That is the word that I'm looking for, factorization. In this case, you can actually like divide it by 3 to become something like this. I don't know if that is good practice in our syllabus, but in SPM, yes, that is good practice. And then we are going to factorize it. It's gonna be, okay, so x squared minus 4x plus 3. So I'm gonna get x minus 3 and also x minus 1 equals to 0, where x is equals to 3 or s is equals to 1. So now we've already found our x coordinates. Let's use the x coordinates to find the y coordinates. So I'm just going to substitute the x coordinates into the original equation. Okay, so let's put y1 equals to 3 cubed minus 6, 3 squared plus 9, 3 plus 20. So hold on, let me just put that in the calculator because I'm too lazy to find it out myself. So 6 plus 9, okay, plus 20. So that would be 24. And then for y2, sorry if I sore throat, that's gonna be 1. Oh sorry, this is not 24 lah. Wait, I got it wrong. 20 I think. Hold on. Plus 9. Okay, plus 20. 20. Apa yang 24 ni? Okay. Tak apa. And then we have 1 cube minus 6, 1 square plus 9, 1 plus 20. Okay, so let's plug that in. Now it's 24. Yeah. So the answer here, oh wait, I wrote it in the wrong place. Here. So the answer here would be when x equals to 3, it is 20. And when x equals to 1, it is 24. Okay, so find the minimum cost of the construction. This is where we are going to use the second derivative because as I said earlier, the second derivative determines the nature of the graph, whether it is maximum point or is it minimum point. So in this case, what I'm gonna do is, okay, wait, let me write down the second derivative first. Okay, let's see. Okay, let's substitute the x coordinates that we got earlier to see what y would be. Okay, so when I have 3, 9, 3, so that is going to be, wait, is my equation wrong? Hold on. Okay, wait, I think I found out where I was wrong at. Hiya, I'll carry this kat sini. Okay, 3 times 2 is 6. It's not 9. I mistook it for squared. So yeah, nasib baik I noticed that. Jeez, okay. So yada yada yada. Okay, that is gonna be 6. Okay, so and then I have c prime prime 1 equals to 6. 1 minus 12 obviously is going to be negative 6. So how do we know exactly if it is a maximum or a minimum point? So for here, since 6 is more than 0, then it is positive. So it is a minimum point. But since negative 6 is less than 0, it is a maximum point. So in this case, we are able to take x equals to 3 because it is the minimum point for the whole cost. Okay, so let's okay, wait, hold on. Is that it? Okay, wait, that is not it. I have to mention something. Okay, so since we know that x equals to 3 can get the minimum point, therefore if we do substitute this coordinate back into this equation, which I'm not going to redo it again, I'm just going to duplicate this here. This means that the minimum cost would be RM20. Yeah, baru dia lengkap. Okay, so yeah, I think that's the end of the question. Yep. Okay, so that's basically it. If I made any mistakes, I am sorry for that, and I hope this video helped. And yeah, thank you. Good luck on your exam too. If I do have time, I'll try to do other questions. I don't know if I do have time, so